Hey everyone, how are you all doing? So, how's the weather over there? In Kerala, where I'm from, it is actually raining here right now. Heavy downpour, but thankfully, electricity and all are still there. I hope all of you guys, whoever is listening to this video, is all safe and sound in their homes. Today, last video, we had discussed about an introduction, right? We just introduced ourselves with the concepts of statistics and data analysis, data collection, and why it is all important to us. Today, we'll understand how to classify the data which we collect. Okay, so once again, welcome to all of you. Welcome to our classroom. And today, our agenda is to discuss on the various methods we can employ to classify our data that we have collected, right? We saw how to collect data in the last class. If you guys haven't seen that video, I'll put a link to it somewhere in this video, okay? So that you guys can go and check that out. It's a very good video to get started into this. And so once we classify our data, we'll also see how to create frequency distributions, and we'll also understand just a quick revision of the terms, the jargons which often pop up when we deal with this data classification and preparation and analysis and all those things. Okay, so none of these things which we are discussing now is a new concept for any of us. We have at least once some part of it, we have studied it in our classes in our school days itself. So it's nothing new, but just refreshing, so that we all have these concepts once again fresh in our minds while we start with our journey into managerial applications. Okay, so why do you think that we should classify data? Do you think that classification of data is essential? I want you guys to comment down in the comment box, okay, of this video, and tell me whether you think that we should classify data or not. Okay, whatever is your opinion about it, please go ahead and get your fingers moving and type it down. Okay, so classification of data. Look at this wardrobe. It's all messy, right? Most of our wardrobes are more often like this than arranged, right? Organized. Our moms have to come and clean it out for us. Or if you're a mom, you have to go and clean it out for your children, right? Otherwise, it's going to be like this. So, what happens if our wardrobe is like this? It's very difficult to get hold of that one sock, okay, right? Or that one tie which we were looking. Or I know I had this pant with me, I can't find it. Now, what will I do? I'll have to pull all my clothes down and search, and then I lose a lot of time, right? Very messy. We never like to do it. So, we need to keep our wardrobes organized, right? We need to classify all our clothes into sections. All our shirts go in one place, all our pants go in another place, saris in one place, socks in another, all those things, right? So it's the same thing with data. Classification of data is actually the process of organizing the data into categories that will make it easy to retrieve, sort, and store data for future use. We can easily retrieve things just like organizing your wardrobe. You can think of it like that. Okay, now see, if it is decluttered like this, it is very easy for us to find out what is where, and we can easily grab hold of things, right? Same like that, classified data will actually condense the data into chunks that help us notice the salient features. We'll be easily able to spot, hey, this is a pattern I did not see when prior to classification. Or just like how you spot, oh, I had this cool looking jacket with me, I never knew it. Oh my god, when did I get it, right? We have that kind of thoughts once we arrange our wardrobes almost all the time, no? Same way. Uh, when it comes to data, it helps us notice the salient features, and it also helps us compare values of different attributes. Okay, just think of it like this: if I have all my shirts hanging in different hangers, I can easily pick, right? Oh, this is from among all those shirts, which would be suitable for my party, or which would be suitable for as a work wear. It is very easy to sort things out, right? And compare. Same like that, it helps us compare values, and it helps us arrange and present data in the form of a table, in a tabular form, and it highlights the significant features of data at a glance. We can easily at a glance grasp the idea or grasp the essence of that data much more easily than if it were unorganized. Okay, so we have different types of classification of data. When you talk about data classification, the first thing, if you are a working person, the first thing that would come to your mind is this: whether your data is confidential, internal, public, private, or restricted, right? In an organization, we have so and so document is confidential, or so and so document is internal for project purposes. We have it, or it might be restricted to only the higher management people. People down below in the hierarchical chain will not have access to it unless your manager shares a copy with you, right? So that kind of classification is actually based on the content of the data of the document, what it contains, the sensitivity, you can say, the sensitivity of the information contained in that document. So that is what this kind of classification is all about. Now, in statistics or in our quantitative techniques, in our uh, uh, what you can say, in our topic of study, more than the content, we are interested in the context of data and classify accordingly. Like, for example, we can classify our data based on geography. Like, we can arrange our data into these are from India, these are from China, these are from Europe or America, like that. Or even within India, maybe this is from Kerala, this is from Tamil Nadu, this is what I'm having from Delhi. So we can see or try to find out the trends based on the geography. Have you used the Google keyword search option? The Google keywords. If you have, or if you have not, if you have, then you would be easily able to relate with me. If you have not, just go to Google and give it a search. Okay, Google keywords. Or I think, or maybe you can, keywords is I think a paid option. You can go for the trends, Google Trends page. Okay, so in that, actually, if you give in a topic to search, they'll ask you to select the country, and if you select India in that, the data, okay, the data will be arranged in geographically. So you'll have that map of India over there. Okay, you'll have India's map, and I am not so good at drawing, okay, please forgive me. So you have the map of India and all the different states over here. The data will actually be classified based on based on the number of hits or the number of searches in each of those. So the state which has most searched for that particular word or that particular topic will be the highest intensity of in color. So like that it is arranged. So that is geographical classification. Chronological classification is based on time. So maybe from, it's like from birth till your death, something like that, how it happened since 1990, and then what happened in 2000, like that. If you are classifying, especially when you talk about income levels and all, right, how the income, per capita income, and or the rate of inflation and all those things were changing. Such data is usually arranged in chronological order so that we can make sense out of it. And other is the qualitative classification based on certain qualities of the data, that is attributes of the data. And the other is quantitative, that is based on some numerical attribute. Okay, so that is how, based on the context or what is inside the data, its context, we classify. And this is the classification, this context based classification is what we are mostly interested in, and not the content based. Okay, so quantitative data, since it deals with numbers, we can classify it again into two, that is continuous and discrete. Discrete is integers, definitely, but it's like it's not continuous as is. Discrete data will be what you can say, discrete values, like maybe 1, 5, 10, like that. It's not continuous. uh, Maybe there is 11, maybe there's a 12, and then maybe there's a 22, I don't know. So integers, discrete values of integers, it's not a continuous graph. Okay, and continuous on the other hand could be integers, it could be fractions, it doesn't matter. But the main thing is there will be a continuity in data. Like for example, the distance traveled, or maybe your income or your age, all those things, like 0 to 5 years, and then you have 5 to 10 years, like that. So the data is actually continuous, it's continuously flowing from your smallest value till your largest value. There is no break point. Whereas in discrete, it's like there is a 1, then there's a 5, then there's a 10, then there's maybe 11. So the values are actually distinct, they are broken. Whereas in continuous, it's all a continuous stream. Okay, so that is the two types of data. And going forward, out of this geographical, chronological, and quantitative, we are mainly interested in this quantitative classification, because that is where the numbers are, that is where we can do our math on. Okay, so going forward, we'll be talking about these types of data. So frequency distributions are nothing new to us. We have already done that in when we were in school, but still it might be years since we all left those things behind us and we have moved forward. So we'll just do a very quick revision of how we can create frequency distributions. So as we told, data may be discrete or continuous. So discrete is usually deals with integers, like say for example the number of children in a family. Or continuous, it could deal with integers or fractions, but it will be continuous in nature, like the income or the weight or age groups, like that. So they are continuous data. Now, what are frequency distributions actually? And actually frequency distributions, when we are talking about its preparation, it's actually very easy. Why? Because a frequency distribution is just a table, a tabular form of representing, and it will have at least two columns. Okay, minimum two columns. First column will have all your values or your value ranges. Maybe if it is a number of children in family in your neighborhood, maybe the values would be 0, 1, 2, 3, maybe 4. Does anybody have more than 5 or 6 children nowadays? Maybe there are, maybe there isn't. Okay, and then so that will be your possible values, right? And then you will have the frequency. Frequency is nothing but the number of occurrences. Say if you took the census for 10 family in your neighborhood, okay, or maybe you took the census of 50 families in your neighborhood. Out of those 50 families, how many families did not have children? How many had only one children? How many had only two children? 3, 4, 5. You get the idea, right? So what was the number of families that had these values for number of children. That value you will write it down in the frequency. If you are talking about the income, maybe you can divide it as 0 to 1 lakhs, 1 to 2 lakhs, 2 to 3 lakhs, like that. So how many families of these 50 you were checking had income in the range of 0 to 1 lakh or 1 to 2 lakhs? That number we'll write it down in the frequency column. Okay, and there we have it. That's our frequency distribution. Easy enough, right? So that is what whatever I explained right now, we are showing it out with an example. Like for example, I took uh, I checked for 10 families to see how many children they had. So first family I went to had 3 children, second had 2, third had 1, again fourth had 2, 1, 3, like that. So I am writing down the number of children. So the least was 0 and the maximum in my neighborhood was 3. So from 0, 1, 2, 3. Now suppose yeah, so 0, 1, 2, 3. So these are like distinct discrete values. They are not continuous. It's not like 0 to 1 child, 0 to 1 child. That doesn't make sense, right? We can't have 0.5 child there. Either you have a child or you don't have a child, right? That's the difference here. That's why this is called a discrete. And see, 0, I had 2 occurrences of 0. So I wrote frequency as 2. 1 comes up 1, 2, 3 times. So I wrote 3. 2 comes out 1, 2, 2 times. So I wrote 2 over here. 3 comes out for 1, 2, 3 times. So I wrote 3 over here. So there I have it, my frequency distribution. This is the when we talk about the what you can say range of values, we have actually 3 methods to find out the frequency. The first one we are seeing over here is the exclusive method. What it means is that, see, we over here what we have is profit and lack of 10 companies. Okay, so the first company had only 2 lakh profit, the second company had 32 lakhs, third had 45, fourth is 20, 15, 4, 42, 22, 29, 5, like that it goes. So 0 to 10 lakhs is I have 2, then 4 and 5, 3, right? So frequency was 3. 10 to 20 lakhs. So within 10 to 20 I have 20 and 15. Now 20, if you see, it is the borderline. Now, whether I include 20 lakhs, that is the bordering value in my upper limit or my lower limit. See, 20 I have over here and here, right? So, where do I include my frequency or this particular data? Where do I include? Do I include over here or do I include over here? That's what the exclusive and inclusive method. I'll show you the other one comes. Okay, so exclusive method is 10 to 20 means 10 is included. So 10 and above, but not 20. So 19.999 is also included here, but not 20. 20 will start from here. If that is the case, then it is exclusive method, and we most often use this method. This method gives the best continuity. Okay, so that is why even though I have 20 and 15, I have only one frequency because 20 is not included here. 20 will be included in this range, 20 to 30 range. Okay, so now I think you can make sense of how I have written the rest of it, right? Now let us keep an eye on this particular uh, second entry itself and see what happens in the inclusive method. So inclusive method, you see over here 10 to 20 I have marked as 2. Why? Because in this the 10 is not included here. So even though we say 10 to 20, what we actually mean is 10.0001 at least, like it's just about 10 is fine. But 10 is not included. Exact 10 is not included, but exact 20 is included. Okay, so upper limit is included, but lower limit is not included. Such a kind of frequency distribution is called inclusive method. So that is why 10 to 20, so 20 and 15 come under this class. And that's why the frequency is 2 over here. And when we talk about 20 to 30, 20 is not included here. So whatever is above 20 and including 30, 30 or below, above 20 but equal to or less than 30 will come in this. That's why here only 2 is there. So that is how the inclusive and exclusive method of frequency distribution works. And one more we have, you might have come across, where we are saying that it is less than 10 lakhs or more than 40 lakhs. Like for example, we have, see, most of our values, if you look over here, is in the ranges like 42, 22, 29, like this, like big numbers, right? But we have very few numbers like 2, 4, 5 and all. So it actually doesn't make any sense to make an entire class. Maybe if there is one more value like zero 0.8, okay, maybe there is a profit of 0.8. So now what do? Can we put a class simply for the sake of 0.8, that 0 to 1, and that because all the others are in the ranges of tens, right? Only 0 to 0.8 is there, so it doesn't make any sense to add a class like this, right? Or maybe there is a one of a value which actually has 70 lakhs profit. Okay, so it doesn't make any sense. Like the maximum value we actually right now have is 45. So if there is a 70, then either we have, and we have taken our class intervals as tens, in tens, right? 10 to 20, 20 to 30. So in that case, what will happen? If I have to include a value called 70, I'll have to create 40 to 50, 50 to 60, 60 to 70, and 70 to 80. All of which these values will have zeros, and only this one value will have one frequency in it. So what happens? The number of classes we have to include just to include this one particular value, this one outlier increases. So to avoid that, what we do is we give the first class will be like less than 10 lakhs and the last class will be like more than something. Okay, so what happens is that these two classes would take care of most of our outliers, and we can, and the most number of values whatever is occurring, that we can include in our proper classes. Like we can divide them into logical class intervals and we can get in that. So that is the open-ended method, but this is where it gets applied, especially when you have very far-fetched outliers in your data. Outliers means data that is very far removed from your normal trend. I hope you understood that. A few points to note over here, that is, we usually use the exclusive method for defining class intervals, but in case if we, the data which we get, especially this happens when we are dealing with secondary data, in case the data we are getting is using inclusive method and we want data in exclusive method, then we can include use a correction factor to get it fixed. So how it happens is that, suppose say we have 10 to 20 and then from 21 to 30, like that. So maybe 11 to 20 and 21 to 30, like that. If it is there, what we'll do is we'll take the lower limit of my second class, that is 21, minus the upper limit of my first class, that is 20. I will divide it by 2. So that is 1 by 2, that is 0.5. Now what I will do with this correction factor is, I will, so we are talking about is inclusive method, okay, that means 20 was included here. Now what I'll do is I'll add the correction factor to this, and I'll subtract my correction factor from this. So what will happen? It will become 11 to 20.5 and 20.5 to 30. Now what will happen? Now I have my exclusive method data. So whatever is till 20.5 will be in my this class. Whatever is post 20 or from 20.5 will be in my second class. So that is how we include correction factors. This is we rarely have to use correction factor because most of the time we use the exclusive method only. But in case you come across inclusive method of frequency distribution, you can always change it to exclusive method using our correction factor. Just keep that in mind. Okay. So pro tip, you should always make sure that your number of classes are it should not be too small that you can't make any sense out of it, or not too large that you have to sit and compute a lot. Okay, keep it medium, keep it adequate enough to cover everything, but not too short, not too large. Okay, and keep them numerically also simple. Like if you have if things are in the multiples of 5, we can easily compute them, right? Like 0, 5, 10, 15, 20, it comes naturally to us. But if it is in multiples of 3 or maybe 7 or maybe 8, I don't know, we can, but there are math minds which can absolutely compute without any ease, right? If you know your multiplication tables very well, it's fine. But for the general public, when you talk about it, it becomes a little difficult when you compare the multiplication table of 5 with maybe 3. Which is easier? 5, right? 5 is the most easiest because all you need to do is toggle between 5 and 0 in your ones digits and you get it, right? So let's always try to keep our class widths numerically simple and uniform as much as possible, and try to start the class with a 0 or maybe any multiples of 5 whenever possible. It might not be always possible, but check if it is a possibility, and if it is, make sure you do that. It will make our calculations very simple. Okay, and take what is your minimum value of observation, what's the maximum value of your observation. Check if those minimum and maximum are some kind of outliers also, and depending upon the general trend that you're seeing, try to fix the number of classes, and based on that you can fix your class intervals. Okay, so these kind of things actually will come to you automatically as you do more and more problems to create frequency distributions. So moving forward, just to sum it all up, okay, whatever we have learned so far, frequency distributions is just one column with the values and the other column with the number of observations of each of those values. And when it comes to continuous distributions, continuous frequency distribution, we can either have exclusive method where the upper limit of the class is not included, or an inclusive method where the upper limit of the class is also included. And then we have the open-ended method where the lower limit of the first class and the upper limit of the last class is not specified, so that any extreme outliers can also be mapped without having to add a lot of classes or without having to drastically change your class widths. Okay, so a few keywords which always comes into the picture when we are classifying or when we are presenting data. One of them is classes. If you have any difficulty in understanding these keywords, this would be helpful. Classes is just groups of raw data. Okay, and a class interval class limits. We'll talk about class limits. Class limit is nothing but the lowest and the highest values that are included in a class. And the difference between your class limits, right? If, say for example, so 10 to 20 is our class. Okay, so whatever, maybe it is an age of people. Okay, so all the group of people who belong to age group 10 and 20, 10 to 20 years of age will be one class. Just like in school, all the kids in first standard is a class, right? All the kids, just like that. uh, Everyone between the age group of 10 to 20, if you tell like that, that is one class. So in that, 10 is the lower limit and 20 is the upper limit of this class. So the lowest age that a person can have to be included in this class is 10. The highest age a person can be included in this class is 20, like that. And the difference between this upper and lower limit is your class interval. That is the width of the class. How much can your class accommodate? How much age can your class accommodate? That is your class interval. Now, the midpoint. Okay, the midpoint of this class is the class midpoint. That is the if you were to divide that class, that single class into two halves, then where will you divide the class? That is your midpoint. The sum of the class limit divided by 2. The middle value of the class. Okay. And frequency. Frequency is just number of observations. Class frequency is the number of observations that will fall within our class limit. That is the number of students. In the previous example of age between 10 to 20, the number of people with ages between 10 and 20. That is your class frequency. And cumulative frequency is your cumulative means what? Sum, right? So when it comes to age, you can say maybe 0 to 10, 10 to 20, 20 to 30, all these things, right? So maybe in that population, whichever you are in your neighborhood, there are 5 people who are in the ages 0 to 10. Maybe there are 10 people in the ages 10 to 20, and maybe 2 people in the ages 20 to 30. Consider just an example. Okay, so cumulative frequency for 0 to 10 will be 5 itself, because there is nothing less than 0. There is no age less than 0, right? There's nothing prior to this. So that will be 5 itself. Now for 10 to 20, so this is how you should think. Okay, people less than 10, 10 years, 5. People less than 20 years, how many people? 10 and 5, that is 15. People less than 30 years, 10, 15 and also 2. So all sum of all these things including our class. So 15, 17. So this is your cumulative frequency. That is total of all the previous classes frequencies and the frequency of the class against which it is written. That is cumulative frequency. Now, relative frequency is if we were to what you can say, if we were to represent this frequency in terms of percentage. Okay, so let's do one thing. Yeah, let's cut this out for just for the easiness of calculating. Okay, let's cut this out. Now, total population is how much? Or maybe let's say 20 to 30 also, there are 5 people. So total population is how much? Maybe let's say it is 50, 50 and 100. Okay, just for the easiness of calculation, let's say. So it will be 50, 100 and then 50 means totally 200. So represent this 50 as a percentage. Okay, that would be, so how many percentage, what's the percentage of people falling in this class? what it will be? It will be 0.25, right? So over here it is 0.5, and again over here it is 0.25, and when you compute all of this together, you will get 1, right? So that is your relative frequency. What is the frequency of occurrence? What is the frequency of your class relative to the total population? Okay, so that is your relative frequency, the percentage frequency of the class, that is frequency of the class divided by the total frequency. So this is how you compute the relative frequency. So I hope next time when you hear these words, okay, you can recollect what is happening. So if you have any doubts, please go back to our video, okay, and listen as many times as is required for you guys to grasp hold of that topic. Okay, so if you have any doubts, or if you need any more explanations on any of these topics, surely use your the comment section below this video. Okay, let me know, and we'll create videos to clarify all those doubts. Okay.